You are gliding down an empty bike lane, pushing the throttle to the floor. The motor whines, the wind picks up, and right as you hit 15 miles per hour, the machine jerks. It slows down. You have hit an invisible wall. That sudden resistance is not a mechanical failing of the motor. It is a deliberate line of code. Manufacturers program the scooter's electronic controller to cut acceleration the moment it reaches a specific speed. But an entire subculture of riders views that code as a mere suggestion. Across internet forums and local riding groups, thousands of users are actively sharing methods to dismantle these electronic walls and reach their absolute maximum speed. Bypassing these governors is entirely possible. However, breaking through that invisible wall alters the delicate engineering of the machine, stripping away the exact parameters that keep it safe and street legal. Manufacturers implement these hard limits to comply with federal safety regulations. In the United States, the Consumer Product Safety Commission classifies these devices as low-speed electric vehicles. To legally operate on public roads without a license, registration, or insurance, the scooter's top speed is strictly capped at 20 miles per hour by federal law. International laws are often tighter. In regions across Europe and the UK, speed caps sit closer to 15 miles per hour. And in many areas, riding privately owned e-scooters on public roads is banned entirely. Authorities enforce these rules aggressively. Police routinely stop non-compliant riders, issuing massive fines, and physically carrying confiscated, illegally modified vehicles away from traffic. The moment a rider bypasses the factory limit, they erase the scooter's protected status. A bicycle-equivalent commuter tool instantly becomes an illegal, unregistered motor vehicle. Despite the legal risks, riders continue to seek out workarounds. The simplest and most popular methods require no tools at all, just a smartphone and a Bluetooth connection. Some riders exploit global market differences using the manufacturer's own official app. By navigating to hidden menus and changing their region setting to the USA, they trick European scooters into adopting the slightly higher American speed limits. Other riders take it a step further with the serial number swap. Using third-party flashing apps, they connect to the scooter and rewrite specific digits in its firmware. This overrides the regional code, removing the digital constraints on the motor's physical output. This digital handshake takes less than 2 minutes. It requires zero mechanical skill. But the moment the new code is applied, the manufacturer's warranty is voided, and the scooter violates local compliance laws. When region swapping isn't enough, riders escalate to overclocking. They download custom third-party firmware designed by hackers to entirely rewrite the factory power limits from the ground up. This hack goes beyond speed limits. The custom software commands the battery to supply a significantly higher electrical current, or amperage, to the motor than the components were engineered to sustain. This schematic shows what happens under the deck. As firmware forces the battery to surge excess current, components turn bright red from massive thermal stress. Sustained heat destroys internal wiring. Battery cells degrade, and the controller suffers catastrophic failure, leaving a dead, bricked scooter. Software hacks cannot bypass hardware physics. Forcing a standard 600-watt motor to pull over 800 watts trades long-term reliability for a brief adrenaline rush. The final tier of modification leaves the software behind entirely. This requires riders to open the deck casing and physically butcher the scooter's internal electronics. The most common hardware hack targets the limiter wire. Riders locate a specific physical wire loop bridging the controller, usually blue or white, and permanently sever it with wire cutters to kill the factory governor. But the absolute extreme of DIY tampering is a technique known as the shunt mod. To perform a shunt mod, users open the controller and permanently begin soldering extra metal directly onto the motherboard's resistors. This blinds the scooter's power regulation systems, tricking the board into forcing massive, unrestricted electricity straight to the wheels. The performance jump is severe. Standard commuter scooters designed for casual bike lane travel are suddenly pushed to highly dangerous speeds of 30 to over 40 miles per hour. Physically modifying the controller removes every electrical failsafe installed by the manufacturer. The rider is left entirely at the mercy of their own unverified electrical work. Persistent battery stress eventually leads to catastrophic thermal failure. Research from the UK's Office for Product Safety and Standards on personal light electric vehicle batteries outlines the exact thresholds where overstressed lithium-ion cells enter a state of thermal runaway. When those thresholds are breached, the physical result is violent. Spontaneous battery fires consume the vehicle entirely, leaving behind a burnt skeletal frame that requires heavy fire brigade intervention to extinguish. Even if the battery survives the heat, the rider must survive the speed. Data from the Insurance Institute for Highway Safety shows that the probability of severe injury jumps by 40% the moment a scooter exceeds 20 miles per hour. Standard disc brakes, 8-inch tires, and upright frame geometries are engineered specifically to stop safely from 15 miles per hour. They cannot physically manage the kinetic energy generated at 35 miles per hour, making severe crashes statistically inevitable. When those crashes happen on a tampered scooter, the financial traps snap shut. Riders face immediate municipal fines for operating an unregistered vehicle, and insurance companies routinely deny medical and liability claims due to unauthorized tampering. If consistent, high-speed riding is a requirement, the logical route is to purchase a purpose-built, high-performance scooter, natively designed to handle 30+ miles per hour straight out of the box. True riding freedom involves respecting the engineered and legal boundaries of the machine. Recklessly dismantling those limits creates a volatile, illegal liability.